right, so first we have an announcement.
Hi, I'm here from Women in Computing, and we just wanted to invite everybody to our bowling social on Monday night. It's 4:30 to 6:30 at the Union Bowling Courts. I don't know, Union Bowling area.
Lanes.
Lanes, yes. So come to that. It's open to everybody, like anyone in the school of computing. Free pizza, free bowling. So. Oh, sorry, it's Monday, March 4th, 4:30 to 6:30.
Thank you. Okay, so there's a midterm Thursday. So we're going to spend today reviewing and answering questions and such. Also, before we start that, the grades for PS5, I let them go yesterday, so they're out. We'll be grading PS6 the next week. PS7 is out. It's due a week from Thursday, so right before spring break it's due. First step, if you look at the assignment, is to pick a partner, and then you go to a little website I set up to tell us who your partner is. And among other things, that will set up Canvas so only one of you submits. Or no matter who submits, it goes to the group. And also we'll set up a new repo for you to use for your group project on GitHub. So just be aware that's out there. Any questions or problems about anything not related to the midterm? Like, I guess you're not thinking about other stuff at the moment. But yeah.
Will we have PS6 over spring break or after spring break?
Well, okay, PS6 has already been due.
Or 8?
Oh, PS8. Yeah, PS8 will be due the Thursday after spring break. So it's another 2-week assignment, but spring break's in the middle, so it's really just a 1-week assignment. Other questions? Yes?
Will the remainder of our assignments be with our partner?
Yes. The remainder of your assignments will be with your partner. Now, having said that, I've told you sometimes groups don't work out, and we'll do our best to accommodate that. So just let me know if your group is failing, your partner isn't showing up or whatever. It's not the case that the rest of the semester will be a single long project. I mean, like this PS7, you're finishing the spreadsheet, and then that's done. PS8, I'm going to try. I plan to use something I haven't done before. I think it's going to be a one-off project. It's not going to build on anything. I'm going to try to make it a little bit simpler and shorter so that you can enjoy spring break. And then after spring break, there'll be a multi-week project. And so the places where it makes sense to break your group up and reform are, like after PS7 or after PS8. Once we get into PS9, we're sort of going to, it gets harder to switch up because the project continues. But. Any other questions? All right, now I'm going to start with a few of these review slides, and I'm going to switch to a sample exam, then I'll come back to the slides. So we're pretty comfortable in here right now, but I know from the first day of class it can be a lot more crowded when everyone shows up. So it's kind of late to be announcing this, but here it is. If your last name starts with A through F on Thursday, go to L102 down the hall. So I'm putting those folks in that room, and then the rest of you come here. And that way everyone can spread out and hopefully it won't get so hot or you won't be hitting people with your elbow when you write and stuff like that. The exam will cover through the first 6 weeks of lectures and labs, which means through Friday, February 15th. It'll cover PS1 through PS6. The TAs will be going over the exam from 2017 in lab tomorrow. And what you'll see when you look at it, if you haven't already, is that it tends to be short answer questions. Some of them are questions about software engineering techniques. Some of the questions are about C#. You won't have to write large amounts of code. It's just going to be small snippets. You may have to read a method, but you won't be writing large amounts of code. And you can bring a cheat sheet. So one sheet, front and back, printed or handwritten. All right, and what we've done these are the major topics we've talked about. And I have more detailed review information following this, but I'm going to skip to something else before I look at them. So we've talked about a number of software engineering concepts and tools. The tools have typically, well, yeah, not exclusively, but typically been provided by Visual Studio. We've talked about a couple of software architectures, and we have learned some new programming techniques and a lot about C#. So that's the major topics that be covered by the exam. Now, so what I have here is also the midterm from last year. So what I want to do now is just go over this. It's the first time, I don't know if I've even made it public yet. So it'll be the first time for most of you to have seen it. So it sort of simulates a midterm. And one thing you'll see is that it looks a lot like the one from 2017, because I always start with the previous year's midterm and modify it. And so a lot of the questions end up having the same form, although different details. And then I'll get ambitious and make up some brand new questions. So just as a way of reviewing, let's take this exam together. So I can actually write on this thing. So there's a regex. And we're asked, which does it match, which does it not match? So before I do that, I get this question a lot every time a assignment involves a regular expression. And it involves, the answer to the question is always that $sign and that caret symbol. So what's the question I get where the answer is that? Yeah?
What did that mean?
Well, no, they're not asking what it means. They're asking a different question. And my answer is, put a caret at the beginning and a $sign at the end. Yeah?
How do you get the string to only match if the entire string matches?
Right. How do you get a regex to match an entire string? Because despite the fact the method is called isMatch, when you match a regex against a string like this, it's telling you whether any substring matches the regex. And so if you're not careful, you can end up thinking that your regex matches an entire string where it just matches a piece of it. So the caret will only match the beginning of the string, and the $sign will only match either the end of the line or the end of the string, depending on what mode you're in. In this case, there's no ambiguity because it's just one line. So if you want to guarantee that you're matching an entire string and not just a piece of the string, you've got to put caret $sign. Okay, so with that out of the way, does this match? Someone just tell me in English what that regex is saying. Yeah.
The characters lowercase a through lowercase z, 0 or more of them is what the question mark means.
No, oh, hold there. That's what a star would mean.
So
what does question mark mean? Yeah?
0 or 1.
0 or 1. Optional. Okay, go on. So optional lowercase letter.
Followed by a non-optional non-zero digit of 0 or more.
1 or more.
1 or more.
Yeah.
And then followed by another optional lowercase letter.
Okay. So an optional letter, then 1 or more digits, where by digit I don't include 0, and then an optional letter, lowercase letter. So of these, which ones match? Does 8 match this formula?
Yes.
That's good. So that's a sequence of digits, optional letter at the beginning and the end. What about that? No, it's got the letters, but it doesn't have any, it has to have at least 1 digit. This one starts with a letter and then, yep, so that's okay. Too many letters there. Okay. I think we got them all right. So whenever I make up solutions for an exam to use in grading, it's extremely rare that I make 100 on my own exams. I always make a mistake somewhere. So don't take everything. If I say something wrong, be sure and tell me. Any questions about that? Okay. Yeah.
So going above on that regex, the caret means it must include, right?
The caret is a symbol that matches the beginning of the string.
Okay. and the dollar sign means it must match the ending of the string. But
Yeah.
that doesn't really matter because of the question marks.
No? What would happen if we left off, so what if we changed this? So we left off the caret and the dollar sign. Yeah? Would it change any of these answers? Yeah.
Yes, the expression with 5 would change because the substring B88B would then match.
Okay. So that regex would now match this string. In particular, it would match the 8 by itself. It would match the 88. It would match B88. It would match 88B. It would match B88B. There's all kinds of matches you could make if you're not required to match every letter in the input. So by sandwiching it that way, you're requiring the match to involve every letter in the string here. What about this one here? Would it match that?
Yeah.
No. It has to be at least a digit. So this one would still be an X.
So in short, adding those two means that it has to match it exactly with
Yeah.
those two. Okay.
Yeah. Because I would get people that would say, okay, I wrote a regex for spreadsheet cells, and yet it will match something like A15B. When the regex said there had to be letters followed by digits. And the reason was, it was matching that. Because the regex was missing the dollar sign and the caret sign. Yeah?
Are there any other basic regex expressions that you would want us to memorize? You mentioned asterisk.
Yeah, there's certainly, there's question mark and plus and star. Those are repetition symbols. You've got you see this, A through Z, that's lowercase letters. Sometimes you'll see this. What does that mean? Anything but lowercase a through Z. And you can just say, A, E, I, O, U. That would be one of those 5 letters. And then we don't see or in this either, so or is important.
Period.
Yep.
In all of the regex expressions you gave us for formula, you started it with an @ sign. And this
Well,
what was that?
okay. So let's suppose you wanted to use this as a regex. I want a digit, one or more digits, followed by a dot. So dot by itself matches anything, so you have to escape the dot to say I really want a dot, followed by one or more digits. So there's my regex. I want to put it into a C# program, so I put double quotes around it. Now it's a string. What's the problem? Yeah. Right, that will cause compiler errors because \D is not a legal C# escape sequence. And so what you would have to do instead is escape the backslashes to make C# happy. You have to say, I really mean \D plus \dot. Okay, or you could just put an @ sign in front of it. You put the @ sign in front, you're saying, what I put in the string, I mean literally. Don't interpret the backslashes as being special C# escape sequences. So it's not required, it's easier to write that than to write that. Yeah?
So the question mark allows, so if you want an extra letter, I guess, but it only allows one. So for number 5, for example, if you wanted to allow an optional, however many amount of letters, how would you go ahead and do that?
Okay, including 0?
Yeah, I guess including 0, yeah.
Yeah, you do star. A to Z star, that would be 0 or more letters at the end. Any other questions? Okay. All right, here's a method. And you can see that it takes an array of integers, it iterates through the integers. It sometimes it increments count and then it returns count. So the question is, what type of thing is f? How would you declare f in the header of the method up there? Yeah. Okay, it's a delegate because you can see we're applying it to to n there, so we're using it like a method. So it's going to be a delegate type, but in particular, what type? What does it take in back there? Okay, so it's going to be, okay, it takes an int as a parameter, and what does it return as a result? Boolean. And you see that because it takes one parameter, and it's in, which is an int, and it returns, better be returning a Boolean if that if's going to work. So I guess that's what you'd write in this box down here. Okay? Make sense? Okay, now I want a lambda which, if passed as a second parameter, would cause count to return the number of even integers that occur in its array parameter. Okay? So I need a delegate that will take an integer and, well, what does my delegate need to do? To make, I want this thing to return the number of even integers in the array. Yeah?
It's to take that in modified 0, and if it equals 0, then it's even number.
Yeah. So a delegate that takes in an n, and then it tests whether n mod 2 is equal to 0. Right? If you pass that as a second parameter to that method up there, then the method would return the number of even integers in the array, because it would only do this increment when f returned true right there, and it would only return true when n is even. Okay? So what was I saying about, for full credit, do not use a conditional? Yeah, I don't want to see an if. It's just, it doesn't fit in the box, for one thing. It's unnecessarily complicated for another. Just compute the Boolean you need to compute. Okay. Next question is, in what aspect of software engineering does forming and testing hypotheses play a key role? So see, we're sort of lurching back and forth between these very applied C# type things, and now we're talking about a software engineering topic. So I talked about various activities you take when you're doing software engineering. Yes? Yeah, it was debugging was the. So there I encourage you to follow a scientific approach to debugging, where you don't just print out a bunch of stuff and try to look and see what's wrong, but you come up with a hypothesis about what's wrong and then design a test to prove or disprove the hypothesis. So hopefully that's somewhat familiar. Any questions about that? Let me say another thing. So here's the 7, this is PS7, this is 2017's exam, and it has 25 questions, each worth 4 points. And that was always my goal, until I just realized in 2017 that the exam was too long. I like to have lots of questions that aren't worth much each, because then a single mistake won't hurt you that much. But I sort of relented that last year. So this one last year that we're looking at is shorter, but the problems are worth more. So it's sort of a double-edged sword. There's less to do, but a mistake could cost you more points. The final, I'll stick to my 25 questions worth 4 points. Okay. What is a critical section? There are your choices. Let you think about it for a minute before I ask for an answer. You always have fun making up the decoy answers. And I just thought of a good one. It would be like a portion of a program that TA does not like. But what is the answer? C, because it has to do with multitasking, multi-threading, where the critical section is guarded with a lock, and only one task, one thread at a time, could be executing inside the critical section. That was sort of the one technique that I've shown you for doing synchronization between threads. Okay. And this is another multi-threaded question. So you see, I haven't had you really write any programs involving multi-threading yet, so you've only looked at mine. So any questions I ask will be pretty high level. How are locks used in multi-threaded programming, in multi-threaded programs? Okay, I've heard of C, I've heard of B, haven't heard an A yet. What do you think? Yep.
Would it be B?
Okay, what do you think? Is it B or C? B. Yeah, so it's B. What about to prevent threads from deadlocking? Why is that not the right answer? Yeah?
Because deadlocking is one of the drawbacks of using locks.
Right. Deadlocks are a bad thing that can happen when you misuse locks. So you don't use locks too. Locks cause deadlocking, but that's not why you use them. To prevent simultaneous access to shared data structures. Yeah. To prevent a thread from blocking. Well, a lock causes a thread to block. If one thread holds the lock right now, another thread's trying to get it, it will block. So it doesn't prevent a thread from doing that, and it has nothing to do with runtime stacks. Okay, now this one always got complaints about what the answer was. So I want to construct a system that works in stages like pipe and filter architecture. So where do we see pipe and filter architecture? That's PS1. And remember, you can run them like this. You take, what does this mean to do right here? What are we asking the operating system to do with our programs when we invoke it that way from the command line? Okay, so we run A first, and it takes its input from input.txt. And then whatever output A produces is piped to B. So B takes the output as its input. B produces output, which is piped to C's input, and then C's output is redirected to a file. Okay, so when you're writing the program, it says from what source should each program be written to read its input and write its output. So if you cracked open B, if you looked at B, where would it be reading its standard input from, and where would it be writing its standard output to? So does B know about A? You can write B. B has no knowledge of A. You're not going to see a statement that says write to A's output. In the code itself. Yeah, if this was a C# program, you would see it doing read lines and write lines on the console. So B would be reading from standard in and writing to standard out. B does not know anything about A or C. It just knows I read whatever shows up on standard in, I write whatever I want to standard out. The operating system takes care of connecting the pipes together. Yeah?
For this question, have we written read line, write line instead of standard in, standard out? Would that be an acceptable answer?
Well, I say you'll need to write standard in or the name of a file.
Oh, okay.
So, but yeah, that happens, and we would typically accept it. But if you do that first we grumble a little bit among ourselves. then we give you credit. Okay. If you ever work as a TA and see what it's like when your exams are graded, you'll never feel the same way when you take an exam yourself. It's an interesting experience. Hey, what about A? What would be the answer for A? Okay, it's exactly the same. A doesn't know anything about any file. It's reading from standard in and writing from standard out. In particular, students want to write that the input source here is input.txt. From the standpoint of the operating system, that's where the input's coming from. But from the standpoint of the written program, the program is written to read from standard in. The fact that it comes from a file is just a consequence of how it's used. If we reorganize the pipeline, it would get its input from somewhere else. And so this is also standard in and standard out here. And I think this makes students really uneasy to write the same answer for all three. So then they erase and they write in, and then they complain afterward and say, I had the right answer there, but then I erased it. What can I do? Yeah. It would have to, okay, so he's asking, for what structure would the answer not be standard in and standard out? You would have to, if you knew something about the program. So suppose I gave you the pipeline like this. And I said, and by the way, A opens up a file and reads this input from there. Then, instead of saying A read from the standard in, you'd say it reads from that file. But you'd have to know something about the program. In fact, right here, if I said, well, I'll leave it at that. So yeah, I've asked this question a few times and I've fallen out of love with it. So it seems like a bit of a trick question. I don't like trick questions. So. Okay, what is the primary purpose for OutParameters? Yeah?
To assign a local variable to that parameter.
He said to assign a local variable to that parameter. That's not what I would call the primary purpose. Yeah.
Well, it allows you to return two different values.
Right.
One method's called.
It gives the method access to the variables.
Yeah, the reason you use OutParameters is it allows multiple return values. I need to find use a thinner. Okay, I mean there's a lot to know about OutParameters, but the reason you use them at all is because you need to get 2 pieces of information or 3 pieces of information back from a method, and you can only return one, so you can send the rest back via OutParameters. Yeah?
What's the difference between a ref parameter?
Okay, so what's the difference between saying I've got some out parameter, say out int x, versus ref int x? What's the difference? Yeah.
If you do the out int x part, you can't take the value in.
Okay. So they're both called by reference in that the method we're calling will have access to x. With OutParameter, the method cannot depend on, it can't look at the value of the incoming parameter. It cannot depend on the incoming parameter. So if I'm over here, if we're calling f, and we're passing x as an out parameter, and up here I say out int in, I'm not allowed to look at the value of in. In may be uninitialized, but I'm required to assign to it. So it's one way. Information cannot come in via that parameter, it must go out via that parameter. Ref is 2 ways. So if they got rid of, what if they said you couldn't use out anymore, and so you had to change all your out parameters to ref parameters? The only thing that might happen is that you might be told that you had forgotten to initialize a variable before it was passed to the parameter, because you don't have to initialize an out parameter before it's passed, but you do a ref, like any other variable. Any other questions about that? Okay, so, if you have a singly threaded program, we have 1 stack, 1 heap, 1 program counter, 1 copy of the program, and it runs on 1 core. So if you have a multi-threaded program with n threads or n tasks, how many stacks do you need? Right, there's 1 stack per thread. That's basically what defines a thread. It's running and it needs a stack to do that. How many heaps? 1. All the threads, at least in C#, Java, the threads all share the same heap. Program counter tells you where you are in the program right now. So how many program counters? Yeah, 1 for each thread, because each can be at a different place. How many copies of the code do you need? Just 1, because why would you need more than 1 copy? It's read-only. It's not like you can change. So all the threads can read the same program. How many cores do you need to run an n-thread program? Yeah, well, you can get by with one. Okay? Your processor happily runs, you know, if I do control out del right now, we'll see like 75 or 100 processes all running at the same time on my 8-core machine. And if it only had one core, they'd still be running. They just take turns. And that's what, if you have a multi-threaded programming with more threads than cores, they just take turns using the cores. So if you're doing multi-threading to get speed up, you know, just having one core for your n-thread program is not good, but it'll at least run. Any questions about that? No, I don't like this one. I can't remember the answer. What are the 5 major phases of the software lifecycle? Yeah?
Analysis.
Okay, so let me write that then. So there's analysis. Yeah. So analysis is where you figure out what system you want to build. Okay, what's next? Design is when you figure out how you want to build it. All right, implementation is where you build it. Okay, what comes next? Testing. And then what? Yeah, maintenance is the official answer. And people always want to put debugging in there, and but that's, if you look at my slides on the 5 major phases of the software lifecycle, that's what it says. And just as a point, what's changed over time is it used to be we used waterfall process, which, you know, followed these phases, but they took months. Each one took months to build a large system. Now, agile processes follow the same, you know, they still do analysis, design, implementation, testing, and maintenance, but they're iterated quickly over, you know, a week or two. Then do a little more simple system, a little more complicated system, and so on. That's the more modern way to approach it. Okay. So you take a test from me, you're probably going to see a question about bin, bit, diddle. And that's just because when I had a professor when I was an undergraduate, that was his character on exams, bin, bit, diddle. And usually bin, bit, diddle did something stupid. So that's a clue. So so bin, bit, diddle has the spreadsheet class. He has that dictionary that holds the cell objects. It maps cell names to cell objects. And then we have the instance variable that says whether it's modified. And it passes almost every test when the tests are run sequentially and fails almost every test when they're run simultaneously in separate threads. So that's a short way of asking, what did bin do wrong? So what did bin do wrong?
There's the static dictionary.
Right.
Since all instances of the abstract spreadsheet are going to share the same dictionary.
Right. So by declaring the variable static, now every spreadsheet you create is going to share the same dictionary, which obviously isn't good. Now, why would it still pass most of the tests? Because I bet most of the tests you wrote for the spreadsheet class only ever created one spreadsheet, right? You create a spreadsheet, did stuff to it, made some assertions, end of test. On to the next test. Only if you created a test where multiple spreadsheets were created and modified would you fail the test. But what would happen if all the tests were run in parallel on separate threads? Okay, now you've got these spreadsheet objects, but they're all still sharing the same static representation. So suddenly all the tests start failing left and right because they're all interfering with each other. Okay, so it's an easy mistake to make, and it's hard to know you've made it until until someone shows you the right test. Okay, so here we have 2 static methods. For each int in G, so G has a yield return that returns enumerates ints. So for each one we write it out, and if n is greater than 1, we break. And then we write 20. And the question must be what's written, right? Prints out some numbers. Okay. So basically, you have to look at this thing and see what it is that it does. I'll let you take that in. I must have been. Yeah. So what happens is I make typos on these mistakes. I correct them during the exam, and then I forget to update my original, and this is what happened here. Okay? That's another lesson for you. Just like I never get 100 on my own exams, I very rarely do I make up an exam without a mistake. So, all right, so what's going to get printed? So F gets called. Then it's saying, okay, give me the next integer, G. So what's going to happen down here in G? It's going to execute along. It's going to get to this point. It's going to return 0, which gets printed up here. All right? Then this loop is going to go back to the top and ask G for the next inf. So what's it going to do? It's going to pick up where it left off and execute this line. So the first time we asked for a number, it got all the way to here and yielded 0. Now it's going to get here and print out 8. And then it's going to go back, add 1 to I, and return 1. What's that thing going to do up there? It's going to print out 1, and then it's going to break. So what happens when that thing breaks? What happens to G here? Yeah?
Is the one greater than 1? Do we break?
Oh, you're right. I was looking at 0. Never mind. 1 is not greater than 1. Sorry. So we printed out 1, we loop, and it asks for the next end, and we come down here, and it just finished, it printed out 8. No, it yielded 1, so it's going to print out 7. Go back around, increment I, and yield 2. The 2 will be printed, and then it stops. Thank you. Yeah, if you break out of the for each loop, then the iterator goes away. So the point is, it's not like this thing runs to completion. So if this thing generated the entire sequence, and then that thing consumed it, it would print out 0, 1, 2, it would print out what? 8, 7, 6, 5. And then the upper loop would start printing. But the point is, they bop back and forth, conceptually. Yeah?
Is it not going to print out the 20?
Oh man, see, I wouldn't have done very well on this at all. Yeah. Yeah, the loop ends and then it prints 20. Any other mistakes I've made? Okay? Yeah?
Is there a scenario where a method that has a yield return would print the 30, or would it never get to there?
Oh, sure. Suppose that loop up here didn't have a break. So what would happen is eventually I would be, we would yield, right here we would yield 3 and print out 5. And then we come up here and I would, next time we're asked for an integer, we'd come up here, we would add 1 to I, become 4. The loop would end. And we keep executing, because who knows, maybe there's a yield return down here to execute. We keep executing until the method ends. So we print out the 30, and then we hit the end of the method, and so it would report back that there are no more integers. You just have to, as long as there's something that, as long as that loop up there runs long enough to suck all the integers out of this loop, we're going to print the 30. Yeah?
So with the yield return, so when you go back up to the previous loop, until G is called again, it doesn't finish that loop within G. And then once the G is called, then it finishes and reenters that loop within G.
Yeah, so, yeah. This guy down here, as soon as it executes a yield return, it stops right there. That's supposed to be a stop sign. Stop. Conceptually, what happens is it just stops and remembers where it was. And then when it's asked for the next integer, it picks up where it left off. In reality, it's very different, but it's easier to think about this thing conceptually. Yeah.
If you encountered a return statement that did not have a yield keyword before it, would it just end the iteration right there?
So you're saying if I had a return statement in here?
Yeah, so let's say you had like an if statement right after the yield return I that was like I is greater than 2, and then on the inside it would have a return.
Yeah.
It would not go to values of I of like 3.
Right, so you can't have a return in a method like this that has yield returns. What it's called is, what you want is called break return. That's really screwy in my opinion. Break return ends the iteration. Okay? So like right here, if it said yield return I and then said break return here, it would yield 1, and then the next time you ask for a number, it would say there aren't any more because it would execute the break return and end the iteration.
What if we just put break instead of break return?
Okay. If you put a break here instead of this, like if you put a break right here inside the loop. Well, so let's see. When you first ask for an integer, it would yield 0. It would print, and it would yield 0, and stop, pause. Then when whoever's using it asks for the next integer, it would print 7 or print 8. It would hit this break, and what would happen? It would exit the for loop. It would print out 30, and then the method ends, and that tells the for loop, no, you asked for an int, but there are no more ints. So that for loop up there would end, and then it would print out 20. Okay, now this question is much easier than the one similar to it that's on the exam I gave you to look at earlier. Right, that was a recursive iterator, which is dizzying.
Are you thinking about doing that again?
No, that's another one I think I have to scratch off my list. Yeah. Okay, let's take a few minutes off and we'll look at the rest of this and then some other stuff. Let's see, back to this. Okay, any other questions about this iterator here? Okay. Well, there are lots of differences between classes and structs, and which makes questions like this a little hard to grade. But what's the major difference? If you could only say, you know, yeah, I'll give you.
Struct is instantiated. Doesn't have to use the new keywords.
Well, you do use the new keyword with a struct, so it's not that. Yeah.
Structs are stored on the stack.
Okay, so that's, you know, it's easy to say structs are stored on the stack and objects on the heap. It's true objects are stored on the heap, but you can be more precise about structs. So yeah.
Structs are stored in place.
Structs are stored in place. Okay? So that distinction, you know, it's an important distinction. So if a variable contains a struct, then if that variable is a variable that's stored on the stack, then the struct is just stored physically right there. So it's stored in place of a reference to the heap. But where's a case where a struct could be stored on the heap? Yeah.
In an array.
Okay, suppose you had an array on the heap that was an array of structs. So every array entry will be a struct. If it were an object, it would be a reference to somewhere else in the heap where the object was stored. So with a struct, the difference is if you've got a picture of what your memory looks like and everything's an object, and you change some things to structs, then before where you had a place with an arrow to another place on the heap, that thing on the heap would actually be stored in place of the arrow. So it's not stored indirectly, it's stored in place directly. Yeah. Go ahead.
Would it be wrong to say structs are treated as primitive types?
Yeah. I mean, the answer is they're stored in place just like primitive types are. Structs are called value types, and primitive types are also value types. So there is that similarity. But it's a little strong to say they're treated like primitive types.
So would you say that classes are reference types?
Well, yeah, classes are, classes provide reference types, structs provide value types. So I would have to accept that. But what I'm really after is the understanding that value types are stored in place, reference types, reference values, are stored at one level of indirection. Yeah?
Just to make sure, a struct within that array would be in the heap?
Well, the array is in the heap, and the struct will be physically contained in the array, so it'll be on the heap too. But the difference being that if it were an array of objects, the array would only contain references, and the object would be stored. Okay, so objects can be shared because you can have two references to the same object, but structs aren't shared because they're not stored via a reference. If you have two different structs, they're in two different places in memory. All right, so I've had a lot of questions that I've answered this week with use a profiler as the answer to the question. So what was the question? Yeah.
How do I speed up my program, like staking all around?
Yeah. How do I speed up my spreadsheet? I'm failing a lot of people failed once they went to, so you had the stress test from PS5, and then when you had to add extra code now on PS6 to evaluate things, and then started failing the PS5 stress tests as a result. And people said, should I worry about it? And I said, I'm not sure if you should worry about it, but if you want to fix it, I would suggest profiling. Did anyone do that and find out anything interesting? What did you find out?
I found out that my lookup method was causing me like 75% of the time.
So
that specific spot.
you look up for formulas?
To find the values of the variables.
But was there anything you could do about that?
Yeah, it was just a simple, like, I had some code that I didn't actually need in there,
Mhm.
so I was doing extra work, basically, and I took it out and it went down to 30%.
Okay. So having said all that, what is a profiler? Yeah? Yeah, it shows you where your program is spending its time, or where your program is consuming its memory. So to speed up a program, to make it run faster, you've got to know why it's slow. You can't just say, I'm going to make this code faster if that code is never executed or isn't executed very often. So that's what a profiler is for. Yeah?
Can memory and time be considered the same thing in profiling?
He's asking, can memory and time be thought of as the same thing? Not really. I mean, they're two different resources, and a lot of times there's a trade-off where you can make your program run faster at the cost of having more space, and vice versa. Okay. This is a kind of an obscure question. I think the last one is certainly reasonable. What's the purpose of an XSD file? You all used an XSD file in PS6. What did it do? Yeah?
Doesn't it declare the format for the expected
Right.
XML file?
So you can think of it as a spec of the format for an XML file. So it says what kind of tags are allowed, what kind of attributes are allowed, how can they be nested, how many can there be. Yeah?
Would that be the same thing as the schema?
Yeah. What's an XSLT file, XSLT file? You really had to be paying attention to get this one right, yeah.
Was that like the background settings?
Background studies?
Background settings that like more specific on it?
Yeah, no, that's not what that was. Yeah.
It's a way to style the XML.
He says a way to style the XML. It stands for, the T stands for transformation. So it's a way to define a transformation from an XML file to some other format. And I gave an example of translating, maybe the T stands for translate, but anyway, taking an XML file that had information about states and running it through, using XSLT file to map it to an HTML file with the same information, or an ASCII file. So sort of a non-procedural, non-programmy way to define the transformation. But admittedly, kind of an obscure question, since you hadn't done anything with it. Here's another one about value and reference parameters. So you can see F takes two parameters. One is a ref parameter, reference passed by reference, and it sets A to 7 and it sets B to A. And down here we have an array of two elements, and look what we're passing as parameters. The first array element, the first array reference is the first parameter, and the second one is the. All right, so what's going to happen when we make this call? What is going to be the final value? What's going to be left in the array when we do this? So this is a good place to draw. You can think about a stack diagram. So down here in G, we're going to have a variable vals, and what will it reference? It'll reference an array out here on the heap, and that'll contain 1 and 2. Now, when we do this parameter passing, we're going to have an A and a B up here. What will the value of A be? Okay, it'll be 1 because call by value, we just evaluate that, and that's 1, and that's what's passed. What's the second parameter B going to be? It's not going to be 2. It's going to be a reference to the place, to where the parameter is stored. So we're passing that array location by reference. So when we say A gets 7, that changes to 7. But when we say B gets A, we come down here, A is 7, we're going to get rid of this and store 7 there because it was passed by reference. Yeah?
Is passing a ref into a method pretty much the same as in Java passing like a wrapper of a primitive to
He-
in terms of
he's-
how they modify and get returned?
Okay, he's asking me to compare what we're doing here, passing a ref parameter, to in Java passing a wrapper around a primitive type. No, it's very different. And they have very different purposes. I wouldn't compare them. Yeah?
So if you were to use out in that instance instead of ref, what would that do?
Okay, so question is, what if we made that an out parameter? What would it do? Would it do anything any different? Yeah?
Don't you have to declare it outside? Or no, sorry, that's what
Well, we'd have, down here we have to say out for sure. Yeah?
In this instance, it'd be the exact same thing.
Yeah, it's the exact same thing. What could we do to make it different? Make it behave differently?
Not include B in void F.
Well, assuming we call the same way, what could we do differently inside F here so that it would behave differently with an out parameter than it would with a ref parameter? Yeah.
We have to read the out parameter at some point to see what its value is.
Right, so if you did something like this, A gets 7 plus B. Okay, you're not allowed to look at a ref parameter until you've stored something to it locally. So right here, this wouldn't even compile because you're looking at, your code is depending on the incoming value of B, and you're not allowed to if it's an out parameter. That'd be the only difference. Yeah?
So if you have an out parameter and so say we had B, we said B equals some value, and then we tried to access that value within the method like we just did, would it compile then, or would it still say, hey, you can't access this?
No, sure. If we said B equals 3, then everything's fine.
So as long as we declare a value inside our method, we can then access it, but we can't.
Yeah. The rule is the same. If you write a method, forget about out and ref parameters. If you write a method and you have a local variable x that you declare, you're not allowed to use x until you give it a value, and the compiler will complain if you don't. So it's just treating this out parameter the same way. It's just saying you can't use it until you give it a value. Okay, any other questions about that? Yeah?
When we say B equals A, are we setting the place in the array still where B lives?
Right, so when you assign to a reference parameter like we are there, you're not storing anything into the stack frame next to B. You're following this dotted line to you're following this reference to where the parameter was originally stored and changing it there. So that's why I wrote the 7 right here. Yeah?
Are both of the ref keywords required?
Yes. Yeah, you have to put ref up there and ref down here, or out here and there. It's the same thing when you override a method. You got to put virtual up here and override down here. Sorry. Yeah.
Can you overload a ref and out?
You mean have an f that takes 2 parameters, both ints, and the only differ that one is an out parameter, one's a ref?
Yeah, something like that.
I don't know. I'd have to try that out. Okay. What's the key difference between black box testing and white box testing? Back there.
So if we treat the box as a code, you'd say black box testing is where you can't see the code as test it. You write test as a consumer or something. And white box testing, you're writing tests as a creator. You can see inside.
Okay. So you said black box testing, you're testing as a consumer without taking the code into consideration. You're writing solely against the specs. White box, in addition, you can take the code into consideration, and you typically do by trying to get code coverage. Yep, that's all that's asking. Anything you want us to add or ask about that? Okay. So in C#, when you declare a method in a class, a non-static method, you can declare it virtual or you can declare it non-virtual. So what is the advantage? Why would you declare a method virtual? Yeah?
You're basically saying that method can be overridden.
Okay. If you declare it virtual, now it can be overridden. And that's why you declare it virtual. Why would you not? Okay. You weren't ready for, okay. What's the advantage of not declaring a method virtual? Yeah.
You can't override it unless you want to do that sketchy stuff.
Yeah, first forget about new. I think that is sketchy. But so, okay, if that's all it was, though, if you declare it virtual, it can be overridden. If you don't declare it virtual, it can't. Why not just leave open, you could just declare everything virtual and let the user decide whether to override it. Yeah.
It helps with performance because you don't
Right. There's just a small performance improvement. It's more efficient to call a non-virtual method than it is to call a virtual method. The difference is, with a non-virtual method, the compiler can decide which code needs to be run when this method f is called. With a virtual method, it can't be decided by the compiler. It has to be figured out at runtime from the type of the object. So you have to go, to call a method on the object, you have to go from the object to its class, find the method, and call it. So if you, in a language like Java where you don't do this, effectively every method's virtual in Java, that's an engineering decision you're not allowed to make on your own. It's just the language says you always have to pay the price when you call a method. C# had a different, I think that the designers of C# had more in mind it being used sometimes for low-level programming where stuff like this is crucial. Okay, so this one only had, 6 pages. The one I gave you was like 9 or something. Okay, now we didn't talk about everything there is to talk about. So what I want to do is, and remember, you'll go over that other exam in the lab tomorrow. Let's just quickly look at what's going to be covered on the exam and see if you have any more questions. So it's just a dull list of topics unless you ask me a question. And then if you ask me a question, we can talk about it. So I started the first day talking about the software crisis, which, most of my life people have been talking about, certainly for all of my professional life, people have been talking about the ongoing software crisis, which is basically we're not able to write reliable software quickly enough. It takes too long, it's too expensive, it's unreliable when we get it done. We got to do better. And so we're just always trying to do better. But, the demands on software just get greater all the time. So one thing I told you at the beginning of the semester was that one purpose of the class was to let you experience this point here, that techniques that work for small programs don't scale. So have you felt that to any extent? Has the experience of, still having to fool around with formula class 4 weeks after you wrote it to get your PS6 to work, has that been eye-opening or anything? I mean, I hope there's some value to it, yeah.
I think, at least for me, I was used to just Whitebox testing in any kind of unit test. So when a lot of things became private, I was Googling how to test private methods.
Mm-hmm.
And just like a lot of, why the heck is this not working? Or how do I run this? Or how do I access that? So,
Okay.
yeah, like it's very specific scaling and it doesn't work on a larger spreadsheet like that.
Right.
It takes too much time or so.
Okay. Yeah.
I think for me, more than referring back to dependency graph and formulas, it was like the difference between implementing PS5 and PS6, because it was essentially working with all the same code, but now you just added more specs that, for me, I literally had already written a get cell value method as a helper one for me, and so now I had to change everything, and so that one I saw more because it was like doing the same thing but approaching it differently.
Right. Did any of you have the experience of looking at your code a week later and going, what was I thinking? What? I mean, that happens to me all the time. It's like I look at code I wrote in the past sometime, and it's like, man. And you know, it keeps happening year after year after year. You'd think I would get better at programming, but it just seems that I'm always shocked at what I wrote last year. So. All right, so that's part of the purpose of the class. We talked about software engineering, which is sort of the intersection. It's not just computer science. It involves managing people and managing systems and psychology and everything else it takes to get large groups of people to do interesting things together. There's the software lifecycle, which we just talked about. And just to point out, the majority of time on a project is spent in maintenance and often maintaining other people's code. So I have forced you to use version control to various extents. I'm sure some of you have adopted it fully, and others just view it as a way to get your stuff handed in, and that's enough. But going forward, version control is something that makes your life a lot easier if you begin to master it. So definitely do. Have any of you been saved by a remote repo when you lost your machine? Okay. So there'll be a new level of version control in working with a partner. So if you're really, if you're working together all the time, that's not such a thing. But if you're working separately on different parts of the code and communicating and having to merge code, it's going to become, another experience. All right, we spent time talking about testing. I don't know if so these are key ideas that we talked about testing, and we looked at some sample questions I can ask about that. Yeah?
What's integration testing?
Well, it's just, integration testing is what you call unit testing once the units get big enough. So you're just integrating two major independent subsystems to make sure they work well together. These are some things we talked about with debugging. So I had an actual experience with Judy's Law in my office the other day, where a student came in with a program that wasn't working, a spreadsheet, and we finally tracked it down to the fact that when he overrode the string method, the toString method in his formula class, he didn't put override. But isn't that a compiler error if you leave out override? So I couldn't understand why the compiler wasn't complaining about the missing override. He was overriding the method, but he didn't put override. But I was so, we'd spent so long in it, I just said, oh well. And I pointed out, I'm violating Judy's Law. This is going to come back to bite me sometime. So I'm still waiting for it to bite me. But there's something I don't understand. Either that or there's a bug in the compiler, which of course has never happened. So that's debugging. Okay? We've talked about the importance of commenting. I'm not going to dwell on this. That's something we dwell on in the grading. We've talked about a lot of software engineering tools, and they've mostly been built into Visual Studio. That won't always be the case, but there'll always be tools. So, VS provides a way to organize solutions, projects, and files. It provides editing support. It provides, IntelliSense. And it says F1 here, although I'm not sure what F1 does. What's F1 do? Oh, you get help on something. Okay. XML comments, and so on. Google. Stack Overflow. Yeah. You use GitHub. Some from the command. Some of you use it from the command line. Some just in Visual Studio. You've used debugging tools. Hopefully, you've gotten maybe a little better at debugging. And I know from my personal experience that I use breakpoints a lot when I debug, but I almost never use conditional breakpoints where you can say only hit the breakpoint if this condition is true. And I'm proud to say that the student and I did it yesterday in my office, so I remembered that was a possibility. As we move into doing programming with tasks, debugging becomes a little harder because now you've got multiple things going on at the same time to take care of. It's not like you're single stepping through one thread. Now you're stepping through multiple threads. And I believe maybe there's a lab coming up to talk about that. You've used a lot of testing tools. And some of you have used profiling tools. So anyway, lots of tools. For the exam, you just sort of need to know what these tools are for. We've talked about the pipe and filter architecture, which we looked at on that sample exam. Just an old-style way of organizing programs. You've used what I'd call the object-oriented software architecture on the spreadsheet, on the formula dependency graph in the spreadsheet. So you're already familiar with that technique. We've since, it's not on the exam, but we've moved on to talk about the graphical user interfaces. We'll be talking about event-driven programming, about client-server, database programs, things like that. These are, it's hard to make these lists comprehensive, but in terms of programming techniques, iteration abstraction is probably something you've never seen before with the yield return. Using methods as data, passing methods as parameters, returning them, storing them. You may have done that before in Java, but I bet if Java is the only language you've programmed in before, you've done it more in C#. We've started looking at tasks and events, lambdas, sort of new things, properties. We talked about structs. We talked about ref and OutParameters. We've talked about writing command line programs and regexes. So those are techniques that aren't necessarily specific to C#. You can certainly use regexes in whatever language you want to use them in. In most languages nowadays, you can use lambdas, and so you'll see that in other languages. And we talked about what's on here, about the purpose of locks and the idea that each thread has its own stack. So this is something you've introduced, and we're going to be building on. I mentioned I was going to try something different for PS8. So in the past in this class, what I've done is we go into the second long project, and it involves some multi-threading. But I realized that there was never an assignment just devoted to writing simple programs using multi-threading. I ask you to write complicated programs using multitasks. And so that's what I hope PS8 will be, is sort of a simpler program where you can actually write a multi-threaded program before you have to use it in a more serious context. And there's a list of things. It's a lot like the previous list. Things from C# that we've learned about. And I think that was the last slide. We talked about a couple of aspects of modeling. The stack and heap runtime model. I'm not going to ask you on the midterm to draw any diagrams like that. But as you saw, sometimes to answer the questions on the midterm, it's nice to be able to fall back on it and draw the diagram. So, what questions could I answer before we wrap up? Yeah?
We go back one slide, very last bullet point.
No, this doesn't want to go back. Hold on a second.
That should fire events.
Down at the end, define hook and fire events.
Yeah.
So we talked about, I don't know if this made the deadline for it was in the first 6 weeks or not, I don't remember. We talked about events when we were talking about graphical user interfaces. And, you have an event. If you want to be notified of an event, you have to register for the event with that + equal syntax. That's called hooking the event. And then if you're providing the event, someone has to fire the event. You have a question? Yeah.
Will we have to read a UML?
Have to read any UML?
Read a UML and explain what?
No. What should you know about UML? It's basically a modeling language for describing something. Okay, so remember, if your last name is begins with A through F on Thursday, go to 102. Tell your friends.